This is the for experiment 5, and experiment 5 I can show you that this is the handout, and it's the experiment on buoyancy and Archimedes principle. And I open the Word file on the side and the density.jar on the left side, and then we go to the procedure, and on top of the left corner side you'll see my blocks, and I want you to choose the brick. Okay, and you see that there is a mass of 10 kilograms and a tank filled with water here, and record the mass of the brick. So this is 10 kilograms, and I want you to go back to your table, and since you don't have here, I think just keep in your mind that it's a 10 kilogram mass, or you could put it right here in this, saying that brick of 10 kilograms. Okay, and then I want you to go to the next step, which is record the initial volume. It is 100 liters, and I want you to go to the initial volume of the water as 100, and since it is in milliliters, but anyways, just go ahead and do the calculations in liters. That should be fine. And then I want you to go back to your next step, which is use the cursor to lift the brick and drop it in the tank. So now I want you to lift it up and drop it in here, and you see that there is an increase in here, and which is 105, and I need to go and record it right here, which is as 105, and the difference between 105 to 100 is 5 ml. That is the displaced volume. And then you need to find out the weight of the water, which is 1 times this VD difference is 5 times 9.8. This is what I want you to do. 1 times 5 times that, whatever the number you get, that's the buoyant force. And then density of the water, which is that it is 10 kilograms divided by displaced volume. It was 5, so that's going to be your density of that object. And you see that that's what it says right here on the screen, right here, 2 kilograms per liter. So that's what you got. So we did the correct way. So that's the part 1. And then for part 2, I want you to open the buoyancy, which is this right here, and I want you to open that simulation. And on the top left corner you will see a screen with the my blocks and material options. I think, yeah, right here. And then choose the option of brick from the drop down menu, which is again a brick right here. And then you will see a 10 kilogram of mass and water filled in here, and you see that special thing which is a scale underneath the water too. So you know that you have a scale right here, so I want you to put that one. Of course, even though it has the weight, this is the weight you're trying to find out. Okay, so use the cursor and place it on the scale, and you'll see the weight, and put that weight right here. So you know that mass of it is 10 kilograms, and weight in the air, which is 98 right here, as it shows right here, 98 newtons. And then I want you to pick up the same thing and put it in here in this water right here. Now you see there is 49. So that's what I want you to mention right here, which is 49. And then, so now if you want to find out the mass of the water, mass of the object in water, that's going to be 49 divided by 9.8. So whatever that number you get, so which is I think 5 kilograms you get. So that is what is going to be the weight of the object in water. And you're going to find out the density of the object. The density of the object is nothing but mass over um, volume. Okay, and also like in we are trying to find out the density of the object in when it is dipped in the water. Okay, so I want you to use this formula right here, this formula right here. Okay, so which is weight of the object in air, which is 98 divided by 98 minus 49 times 1. Okay, so that's going to be what do we do here, which is 98 divided by 98 minus 49. So that's going to be the density of the object in water, the one which is in the water. And then the buoyant force, it's pretty self-explanatory, which is 198 minus 49. That would be 49. So that should be your experiment 5. If you still have any questions, feel free to answer. Feel free to contact me. All right. Thank you.